Okay, well, here I am. I am ready to talk to you guys about pressure conversions. I really can't believe I didn't get to this last week on Friday, but I didn't, so here it is. I've got a couple questions to ask at the beginning here. What is pressure and why is pressure? If we're going to define pressure right here, thank you. It is the force that's exerted over a given area. That's defined for you right here. I would make sure you have that in your notebook. In formula terms, it's pressure is equal to force divided by area. And for a gas, when we talk about pressure, why do gases exert pressure? Well, remember we talked about how gases are in motion, the particles are in motion, and these particles are colliding with the walls of the container. So whatever you have it in, it could be a balloon, it could be a room, whatever that container is in, gas particles in their motion colliding with the walls of the container exert pressure. Got it? Good. So do liquids or solids exert pressure? And my answer to that is absolutely yes. We call that, are you ready for this? Do you know what it is? Starts with a W. E-I-G-H-T. It's called weight. Well, duh, of course it is. You think of dancing at prom. Why do ladies always take off their high-heeled shoes when they dance? Well, because if they step on your foot with their bare feet, they don't exert near the pressure as they do if they step on your feet with the heel of that high heel. Holy smokes, would that hurt? Force divided by area. Think about it. So why is there a little space between solid particles as compared to gas particles? Well, you got to remember what we talked about, intermolecular AR forces. That didn't get written very well, did it? Oh well. Intermolecular forces, that they are holding particles together. And when they're at a solid and liquid phase, they don't have enough energy. The particles don't have enough energy to overcome these forces, so they hold them in condensed states. For example, if I had 1 mole of dry ice, that would be 44 grams. It would be 28 cubic centimeters as a solid. As a gas, it is 22,400 cubic centimeters gas. So it occupies much more volume as a gas than it does as a solid. So, next question, how can I change gas pressure? You change gas pressure by changing the number of, think about it, of collisions. Okay, so how do you change the number of collisions? You can change the volume. If I make the volume smaller, I'm going to have more collisions, or I can change the number of particles. I can add more or less. I can remove particles. The other way that you can change gas pressure is by changing the energy of, you guessed it, collisions. Okay, so pressure, again, think of pressure, it's being connected to collisions. Now, units of pressure can be in either kilopascals, inches of mercury, millibars, atmospheres, or pounds per square inch. It could be 101.3 kilopascals, 29.92 inches of mercury, 1013.2 millibars, 1 atmosphere, 14.7 pounds per square inch. In fact, there's another one too I should give you, and that is 760 millimeters of mercury. So, why are there so many different units to measure pressure with? Well, I am going to give you this advice. Google it. See what you find out. So, you all have this sheet in your notebooks. You've got gas pressure conversions. There are 10 problems here. We are going to do problems number 1 and 2 together. The given information that you need is right at the top up here. These are all the different conversions. You'll notice that 1 atmosphere is equal to 101.3 kilopascals, which is equal to 760 millimeters of mercury, which is equal to 29.92 inches of mercury, which is equal to 14.7 pounds per square inch, which is equal to 1,013.2 millibars. So, that didn't look right. Let's try this. There. Here's what I need you to do for these problems. You're going to want to read the problem, and then you need to identify the given information. What number am I giving you, and what unit is it involved? You also need to figure out what the desired information is that you're being asked for, and then you need to look along the top of that sheet and come up with a conversion between the given and the desired unit. Then you're going to put it into a grid like this. You're going to take your given information, that goes in the upper left. The desired unit you want to be goes in the upper right, and the given unit, this right here, is your conversion, goes in the bottom. When you do the math, when you multiply and then divide, you're going to get your desired answer. So, what does it look like? Well, here's problem number 1. It says the pressure is recorded as 738 millimeters of mercury. Convert this pressure to atmospheres of pressure. Okay, so you are given 738 millimeters of mercury. You're asked for atmospheres. The conversion, if you look at the top of your sheet, it says that 1 atmosphere is equal to 760 millimeters of mercury. So here I put my given information. The conversion shows up right here. 1 atmosphere, that's what we're looking for over here. I want ATM, and my given unit is 760 millimeters of mercury. So when I multiply and then divide, that's going to give me your answer. So essentially it's 738 times 1 divided by 760. Got it? Or number 2. Number 2 says a soccer ball is inflated to a pressure of 12 pounds per square inch. Convert this pressure to atmospheres. So I am given 12 pounds per square inch, and I'm asked for atmospheres. And I look in the top of that sheet, and it says that 1 atmosphere is equal to 14.7 pounds per square inch. So I put my given information in the upper left times 1 atmosphere right here. That's what I'm looking for. And this is, oh my gosh, I made a mistake. How about 14.7? Oof, that's scary. So 12.0 pounds per square inch times 1 atmosphere divided by 14.7 pounds per square inch. That's going to give me my final answer in ATM. And I'm trusting you can do that math. I really am. So, are you ready? Got it? Now, I got to add a little Calvin and Hobbes in here. Try to be as un-Calvin as you can and finish numbers 3 through 10 in the next 20 minutes. Okay? Thank you very much.